Hello, everyone, and thank you for joining us on today's Senza Fili Sparring Partners webinar, What Do We Need 6G For? Our speakers today are Ern Worthman, Principal of Worthman Associates, Pasquale Cataldi, Managing Director of Innovation Lambda, and Monica Paolini, Principal at Senza Fili. I'm Kendra Chamberlain, and I will be moderating our webinar today. In Sparring Partners webinars, we watch our debaters discuss a topic live on video. We would encourage our audience to participate in the conversation. So please share your comments and your questions using the Q&A button at the bottom of the Zoom screen. All comments are visible to all participants, so please keep the conversation polite and respectful. Our speakers will do their best to address questions as they go along and as they become relevant to the topics being discussed. So please do not hold your questions until the end. And a quick tip for our audience members, please do not share your comments using the chat function, but do share them using the Q&A section instead. Our speakers do not monitor the chat, and we want to make sure that they see everything that you are saying. With that, I'll hand it over to Monica.
Kendra, thank you so much for the introduction, and thank you all guys for registering to this Sparring Partners of 6G, and thanks for Pasquale and Ern to join me. Today we're going to talk about 6G. Everybody talks about 6G, but I will say that we're going to talk about 6G in a somewhat different way. We're going to talk about, we're going to try to get out of the hype versus what do we need it for, that's nothing good about it, we don't need it, and trying to sort of see how does it fit in the wireless evolution. And our views, I think, are a little bit not entirely mainstream. So with that said, as Kendra said, do tell us what you think as we go along, and also ask questions. A lot of you know as much as we do, or even more than we do, so we do value your comments. Just feel free to just tell us what you think, even if it's not really a question. Said that, what I would like to do is to get started with Pasquale and Ern introducing themselves. Some of you might have seen Ern on the previous Sparring Partners, and then we will go with the discussion. So Ern, why don't you get started? Tell us who you are and what you do.
Hi, Monica. Thank you so much for the opportunity here. My name is Ern Worthman. I'm the principal of Worthman Associates. It started out as an editorial and technical writing company way back when, and it's progressed into a whole bunch of different things: training, analysis, editorial, things like that. And today I do a lot of speaking, and I do a lot of editorial, working for different magazines, writing things on the edge of the envelope, and of course seminars like this for different organizations. Briefly, I'm an engineer, senior member of the IEEE. I used to lecture at Colorado State University's engineering department before I moved out of Colorado. And I have clients that I work with on the high-tech end of things. That's all the good stuff. Next.
That's you.
Yeah, thank you. Thank you, Monica, for this chance. And it's a pleasure for me to be here to discuss this topic with you and with Ern. So just briefly about me, I will be very, very brief. So I'm a consultant based in London, and my work is to support companies and policymakers with innovative and sustainable technologies, with particular focus on wireless communications. Now, I'm as well like an engineer by background. I'll be spending more and more of my time on policy matters, and I'm quite passionate about spectrum and innovative ways to use spectrums, in particular, anything that requires more users to use this constrained resource, from sharing, dynamic spectrum sharing, and all the rest, which I think will definitely have a role in 6G, but we will get there probably.
Absolutely, yes, and yeah, I think that's that's actually how I got to know Pasquale, is to talk about spectrum in a somewhat different way. So anyway, let's get to talk about 6G. So let's do something different what we usually do. So what I'd like to do is to just get each of us just have a very brief statement about what we see, what we think about 6G, and then we're going to discuss, just so that you guys in the audience get a sense of where we stand and what we are, about. And I'm going to get started. So as far as I see, 6G, is it going to be a success? Yes. Do we really need it? No, but it's a good thing to have a better interface and a better technology. So I don't see why not. We don't need it tomorrow. Otherwise, it's going to drop that tomorrow if we don't have 6G. But at the same time, I think that we need to look at it as 6G, not as just the next generation, but it's just a way to open up the way we use wireless. And I think we need to look at it. We also need to be open to other technologies, or to think of 6G in the context of spectrum sharing. And this is why I think that we're going to be spending a lot of time talking about spectrum. And for all the new applications, yes, do we need 6G? Yes, we do need it, but it's going to be also like, things like metaverse is going to be, most of it is going to be Wi-Fi, not 6G. So we need both of them. Done. Pasquale, you're next.
No, yeah, this is excellent, and I would start from acknowledging that at the moment where we talk about 6G, we do not really know what we are talking about, and so I mean, there might be people that know exactly what they're thinking about when they're thinking about 6G, but I'm not one of those, and in a way, I envy you. I would take a step back and look at, as an engineer, what problem are we trying to solve? So the first thing is to try to identify a problem to solve. And then we can then label the solution to that problem, 6G or whatever we want, but we should start from a problem. Often engineers do not get their way. And so we start from a solution and trying to look for a problem that can be well suited to that solution. So just to keep it grounded to 6G, at the moment, it would be great to understand whether we are talking about a new IMT generation, or whether we are talking about a network of networks. And I'm talking about that because we already seen in the 3GPP standard, in release 17, if I remember correctly, there will be non-terrestrial networks that will play a role, and we would see that to increase. So at that point, we need to really think, are we just talking about IMT or more? And based on that, we probably can have two parallel and potentially diverging conversations, or ending up with different considerations. And I will stop there. There is a lot to add to this.
Yeah, so if you joined thinking that now you're going to know everything about 6G, you're going to be disappointed. Okay, so that's result number one. Ern, let's get started. What about you?
Yeah, so, both of you made very good points. And Pasquale, your discussion about spectrum, and we discussed yesterday, you came up with the term network of networks, which I just glommed right onto, because I don't think I've heard a better description of the future of wireless than that. I've come into both 5G and 6G from a practical perspective, more of a naysayer type, and that I'm always the person who wants to get the hype out of the way and get down to the technology. Unfortunately, as you said, we engineers don't always get our way, because the marketers come to us and say, hey, I got a problem, you got to fix it. That's what we do. So I feel your pain on that one. But the hype for 5G has worn off. 5G is now pretty much just behind the scenes. And I believe 6G is going to be just an extension of that. I don't believe 6G is going to be an element that we can put our finger on and say, that is 6G. I think what we're going to have, what 6G is going to be is simply a concatenation and a culmination of all the wireless technologies that we're going to develop, have developed, and they're going to be networks within the network, and the overall network, the global network, will be whatever the next generation of wireless brings, whether it's an extension of what we have in 5G, whether it's up in the millimeter waves. Satellites will play a role in this, of course. All of this will come together. So going forward, selling 6G the way we sold 5G, it's not going to work for anybody. And we have to realize that the platform we're going to get, what are the problems and how are these platforms going to solve those problems? Again, back to Pasquale's point.
Okay, very good. And that kind of resonates with the audience because we got two questions along those lines. So Shamin is asking, is saying that many people and colleagues always keep asking what benefits 6G will bring to us that we are unable to fulfill with 5G now. And then Alex is saying that 6G is being driven by governments who are setting out requirements they want to see in their societies, coverage, accessibility, sustainability, and IT is putting together requirements based on government visions globally. We're going to get back to that. I think this is a bigger argument, like, what's the role of government here? But why don't we get started addressing this question, but also defining what do we mean by network of networks, and then talk about, what is that? So I guess my really the quick answer to, is 6G going to do anything that 5G is not going to do? No, but that was true for 5G as well, right? So 5G was not, we didn't need 5G to do something that 4G was not able to do, period. It was not able to do it on scale. So that's true. But anyway, why don't we get started defining what network or networks is, because that is going to take us back to this topic.
Pasquale, I'll let you start.
That's you.
Yeah, no.
Put you on the spot here.
No. That's great, and I'm happy to have a go with that. I think what is important when we look at 6G is again, like, let's look at how people and machines or whatever, how we are consuming data, right? And what we see is that there is the great majority of the traffic is actually generated while you're fixed and not while you're in mobility. And the great majority of the traffic is also generated while you're indoors, right? So if we were to limit 6G, or our understanding of 6G is an IMT solution, then we would expect that the KPI would be to deliver upon like fixed connectivity and indoor connectivity, right? But do we really need to go there? Because there are other technologies that can deliver that. What makes IMT unique is the mobility bit, the high mobility bit outdoors. So, so if we were to limit 6G as an IMT, then I think we are pretty constrained. And I agree completely with Monica when we say, well, it would be an evolution, something, optimization or something that is already on the path. But it wouldn't be a game changer. But now, if we actually look at, let's say, our description for 6G is more like a network of networks. And what I mean is going to be an IMT that is working together with a satellite connection with HIPs, so high altitude platforms, systems, or with Wi-Fi or whatnot, personal area networks like Bluetooth, ultra wideband. Then this is what I call network of networks. Then we can see that then we are in a different scenario where each type of network or technology can deliver upon their best suited KPIs, and just all together they will work together to deliver the applications that are the ones for 2030s and beyond. So this is my point of view. And maybe I would like just to give a little bit of data at the moment. If we're talking about just an IMT data, we've got like 90%, in general, 90% of the traffic that that is generated is on fixed networks, and only less than 10%, 5% is on mobile networks. And 70% of the traffic that is generated on mobile networks is actually consumed indoors in a fixed location. So we need to really try to understand, if we want like to think about the applications, the future applications, let's take a step back from the specific technology and try to address, as engineers would do, what bits need to be improved and how we can tie everything together to make it work better.
Okay, so I need to kind of say something here, because this is something that it's very dear to me, that I already talked about it. So we often talk about mobile networks or cellular networks, and I propose to, and I usually do now, I try to talk about wireless networks and connectivity, because Pasquale, as you say, I actually think that it's even more than 70% that it's indoors, but does it? Okay, we actually, it's very hard to get that number down. Okay, yeah. But we know that it's over 70% of usage is indoors. So it's fixed. It's not mobile in the sense that you are in a car. Also, 70–80% in every country is actually not even going through cellular, is going through Wi-Fi. So the amount of traffic that really requires mobility, like handoffs and all that, is very small part of the traffic. However, that traffic is incredibly valuable. So 1 bit of mobile traffic is much more valuable to us. You know, when we're going around and you need to do something, that is more valuable. So we need to keep that in mind. Okay, but I think that we should talk about, when we talk about 6G, 5G, or Wi-Fi, we need to talk about wireless rather than mobility, because that's more accurate of what we are actually doing. And so, and again, when you talk about network of networks, we already have a network of networks in a way that we use multiple networks. The problem is that those networks don't talk to each other well. We don't go from one to the other with the kind of network of networks approach that I think you're aiming at. So yeah. That is that I think it's going to make an issue. And I think, Ern, I mean, we previously talked about, you know, that also is going to be a particular challenge for, I mean, the reason why the network of networks is relevant for 6G is because we're going to start using higher frequencies, and that changes the game. Right?
A lot. Yeah. The thing about network of networks, and you guys touched on, you know, most of the salient points about that. The way I look at it from a technical perspective is that you've got all of these disparaging networks out there, starting with satellites and low Earth orbit satellites. And then you talk about Wi-Fi and then Bluetooth. And then you have, you know, even your indoor next and your even down to RFID, a few millimeters. These are all different kinds of networks. So the biggest challenge from a technical perspective with 6G, and this is, I think, where 6G or quote, the environment of 6G is going to play its real role, is how to connect all of those, including, and we talked about this yesterday, so how do you get all of these signals in and out of every place you have to go? You know, you can black box networks, 2 in, 2 out, that's easy, but where do you find the receiver and the transmitter, the transceiver parts? How do you get into that? And we had mentioned the term RIS when we talked about that, because you can't have billions and billions of antennas 3 inches apart for RFID, or, you know, 3 miles apart for cellular. We can't do that. So we have to come up with a new type of dispersion technology, transmission technology, that we can use as the overlay, that all of these networks can talk to and transfer data back and forth between whatever network they want to talk to. And mobile and fixed doesn't matter in that case, but that's what we need, is we need a ubiquitous umbrella of transmissible materials so that signals can cover everything from a few millimeters to a few 100,000 or even million meters.
Okay, I need to put you on the spot, Ern. I'm the acronym police today. Risk, define it. It's
I'm sorry,
very
what?
exciting stuff, but
Okay.
you talk about risk. Tell us what it is.
Okay, so risk, reconfigurable intelligent surfaces. So what that basically is, very simply put, is everything becomes a transmitter and a receiver. Your desktop, your buttons, your eyeglasses, paint, vehicles, even to some degree, animate or living objects like trees, bushes, and stuff like that. That's a bit of a reach at first. But they've done some work with that already in the terms of conductive paints, which have been used on buildings to act as antennas. There's some other things going on in the research labs to try to make other surfaces reconfigurable or intelligent, not necessarily reconfigurable, but intelligent, so that they know what's going on when they can move. Let's say you walk into your office and you've got your little RFID tag and you walk up to your transmitter, you walk into your building, and that data is going to have to go somewhere. So what's going to send that data somewhere? You can do it through the wired network and off on switch type. You walk in, okay, he's here, and that card is here, and then you can just let it log until that card logs out. But there's other things you can do with that card: computer logins, lights, room controls, all kinds of different things. So all of this is, all of these are networks of some sort, and they all have to find a way to talk to other networks so that it becomes an intelligent set of networks, so things aren't redundant, so things aren't repeated, which takes us back to the utilization of resources, of course, and the spectrum issues.
Yeah.
So that I don't know exactly how they're going to do it yet, but I know they're going to do it.
So,
Ern, may I ask you something? Actually, what you were talking about is like the surface that can be used, right, to direct and enhance also the capability, the coverage, the capacity of networks, etc. That makes me think that unless we've got tomorrow like a surface, let's say that means like a wall or like a facade of a building that belongs to to an operator, it is normal to assume that trick can be used by multiple networks at the same time. And that is, one step away, or actually very close to the concept of neutral network or neutral technology that can actually support the connectivity or the service of multiple operators. And so like we are actually, we're not talking anymore about just like a radio that can be used by multiple mobile operators and serve them and have MNO, VMNO, etc., just to work, but we can actually expand it to the capability of all the networks that will include the surfaces. And this is quite interesting concept. I think this is where the 6G is actually interesting, because it could change all the business model and the commercial views of operators, or how to actually deliver the connectivity.
Yeah, let me say something. I absolutely love the opportunity of risk, but it basically uses reflection, and we actually are using it already. We've been using it forever, because sometimes it just works that you reflect the signal and you just take it for free. It's like, why not? But most of the time it's been seen as a problem, because it also creates interference. So with risk, we're going to use that property, the reflective property, in a good way to our advantage rather to our detriment. And as you move to higher frequencies, it's easier to do because the spread less, and so you can do it more efficiently. And think about the fact that if you have passive transmission, there is no need for energy, so it's very energy efficient. Now 6G is not going to be designed specifically for that, because any technology can use it. Reflection is just a physics thing, it's not a standard thing, but clearly there is a huge scope for using it. And I think it's quite exciting how we do it. I'm done. And actually, I would like to do a Sparring Partners only on risk, because that deserves, I think, a lot of attention. But Ern, you were trying to say something.
No, it's just that, this all boils down to one small, funnels down, for a better term, to one particular concept, and that is, how do we get all of this data to have value and to be managed? And spectrum management, comes into play there. But the real thing is, people are going to go out there and say, I'm going to use 6G to do this. You're not going to use 6G to do anything. You're going to use spectrum to do what you want to do. Whether it's 300 gigahertz, 3 megahertz, 300 kilohertz, who cares? That's what you're going to be. So the marketing ploy of 6G, and the marketers who really don't understand that, and believe me, there's plenty of them out there that are playing the game that don't. They come in and say, oh, we got 6G here. How do we market this? Okay. Well, you're not going to market 6G. You didn't work with 5G. You tried to sell it to the consumer and didn't do anything. Now it's free. Okay. Same thing's going to happen with 6G, and nobody's going to care. Nobody's going to care if this is a 6G network or 5G network. They're going to care, how is this spectrum going to solve my problem? As Pasquale, you said earlier, we had a problem, we got to solve it. So what are we going to do to solve it? Who cares? And this is the mindset that the industry has to start developing, and the carriers and the people who want to make money in this have to look at it from that perspective. We're not going to sell it on 6G. We're going to have to figure out how this next generation, or this extended generation of 5G, the expanse, whatever you want to call it, 5G advanced, how is this going to work for us to make money, to monetize it, the verticals, blah, blah, blah.
No, absolutely. And I think you put a very important point. We need spectrum. Now, whether then we use it for 6G or whatever, that kind of sort of detail. We do need spectrum, and we cannot create new spectrum, but we can learn to share it in a more efficient way. So spectrum is, everybody complains we don't have enough spectrum. In fact, we use it in a very inefficient way right now because we don't share it.
We have a lot of old technology out there.
Yeah, exactly. It's nobody's fault. It's just
Right.
like now we have a better way to share it, so we should do it because that's the best way to get more spectrum. And then whether it's 4G, 5G, 6G, Wi-Fi, something else, who cares, as long as we use it. And it's important to really share it in the sense that there's so many non-public uses for verticals. I recently learned that they're using millimeter wave for weather forecasts, and it's absolutely amazing what they do with it. We want to make sure they keep using it, but at the same time, they only use a very tiny bit of spectrum in a very limited way. So we need to really welcome that and not consider them as sort of the boring legacy. They're really exciting stuff that they do, but at the same time, they don't need as much spectrum as available. And okay, now, let me get back. So there's a question from Alex about IoT. And it's actually a comment about, we need more reliable, consistent coverage for IoT for things like rural forest, maritime, logistics, motive, and other aeronautics. I think that for a lot of them, you may not necessarily need the millimeter wave. But I think that this is actually, when we talk about the need for 6G, the way I see it is like, we want to have a technology that is more efficient, more energy efficient, use the spectrum in a more efficient way. So it's not like we absolutely need it, otherwise, again, we're going to stop functioning. But that's a, it's not an absolute need, but it's a nice thing to have. What do you guys think?
No, I mean, I agree completely. I mean, when I look at, Alex's comment, I completely agree that IoT is part, even though I remember back in the days where we were talking about 20 billion IoT devices by this, and then it didn't happen, or it's not. So we need to understand that there will be different requirements. On one side, there will be IoT devices which will require very little capacity in terms of the bands, but they might actually run very important applications. On the other side, there could be, the other spectrum. there is a pun there, but like, why would you use the terahertz or the sub-terahertz bands? Well, to deliver very, very, heavy data transfers. It could be in a very short, in a very small, for small distances, right? Very small distances, right? So we are at the extreme. Now, do we need one standard to cover all these cases? Sure, we can try that, or we can actually rely on the network of network concept, where there will be different technologies that cooperate together and will actually deliver on what they can do best. But this means that also when we look at spectrum, do we need more spectrum for 6G? Sure, or we could rename pretty much everything that is not 6G, which means potentially any non-military applications potentially, as or for science, or something like that. All of that we can call it 6G. And so let's stop to have fights over, I want more spectrum for 5G, or I want it for satellite, or for TV broadcasters or stuff. If they're all kind of like a different flavor of 6G, let's work together. And spectrum sharing should be the underpinning assumption for that, to enable that. I'm an optimist. I know it's not going to happen, but I can try.
Well, I don't know. I think, yeah, you're an optimist, but I don't think it's really, we're not that far. I mean, we're going there. And I think that, again, as I said, we don't know what 6G is, but oftentimes, you think about 6G, you think about 3GPP, kind of like cellular technology. And I think, as you say, it's really important to keep in mind that we need spectrum, and then everybody can use it. Now, I would say that, a lot of time we sort of try to push for, but there is a technical neutrality that regulators have been pushing. And I think it's important to put it at the forefront, because we do have different networks. So for instance, the networks for weather forecasts, it uses a I don't know what technology they use, but it's a proprietary, or it's separate. It's not 6G, but why not? They have the rights, and we want them to use the spectrum. Not only that, but I think that from a regulatory point of view, a country point of view, I think it's really important to foster multiple technologies. 6G is going to be successful no matter what, I think. There is no question there. But I think it's important to, from a regulatory point of view, to actually promote diversity rather than a specific technology, because there is a value to that. So, and Wi-Fi is one of them, but not the only one. It's actually useful to have, because different technologies do different things. And then you get, yeah, sorry.
Yeah. No, so sorry. Like to this point, I think it is useful to think about 6G not as something that will be delivered in one go, right? Also because, again, in this context of network of networks of different technologies, every technology has got a different development cycle. So we've got the IMT technology, so the 3G, 4G, 5G, 6G, that it is every 8 to 10 years, right? But we've got other technologies that are much shorter. We've got Wi-Fi that started, actually, it took a long time within the first generations, but now is on around 3-4 years, even less. If we look at Wi-Fi 6 and Wi-Fi 6E, which is quite different, the opening another band, even though technically it was similar, but actually changed a lot. But on the other side, there was a spectrum. We could have military applications, or we were talking about radars for weather, that where actually these technologies have to last for 20 or more years, and also the first iterations of satellite, that they were designed to last for 20 years and more. And now we've got the LEO, where actually there is a much higher churn of satellites, of technology that can be developed and launched to space, or not to space, but yeah.
Up there. Yeah, no, I think satellite is actually quite fascinating, the latest developments, because if you can use it, it's just, again, it's really nice, especially because it's complementary to everything else. Because it used to be that you have, you know, the satellite network is completely isolated and lives on its own. So I think that that's going to make it so much more valuable as a technology. Ern, sorry, you.
No, I was going to say, spinning back, to the Internet of Things. I've kind of stopped calling it that because there are so many different things that, and so many different internets that people come up with, medical things and vehicle things and this things. I like to kind of more refer to it as the Internet of anything and everything. I call it IOX just because X is always good for stuff like that. But I don't think we quite realize at this point how important the internet is going to be in 6G or in the next generation of wireless technologies. And at one point I had said that everything wireless will be a node on or in the cloud. And so the internet is going to be that collection of nodes, whether we like it or not. It's just, I think if we're going to make a big leap in terms of what's going to happen coming down the road and things we need to worry about, not to worry about, but we need to concentrate on, the internet, as we call it, is going to be that. And 6G and 5G and everything else is just going to be a network in the internet, in the internet network, which will be that network of networks. That will be the technical and the protocol technically for everything that's going to happen. We aren't there yet, but if you think about it, almost everything interfaces to the internet or the cloud really somewhere. So that's going to be the real discussion topic going forward in 5 years or something like that. Once we decide how 6G is going to integrate, how it's going to stratify left, right, vertical, and things like that. And then, of course, all the, like you said, satellites, everything else, it's just going to be a node somewhere on the internet of something, of everything and anything, and it's going to come into it.
Yeah, and I think, it's connectivity here, the idea, what you connect to is just going to be, even at the end, even the distinction between, are you connected to a person or to a device, there is a gray line, if it's something on you, but you're not really using it, is that, or something in your home, what is it? Okay, let's get to the question. So we had a question about that Pasquale addressed. I don't know whether we want to comment on it, but it's going to be a role. Now, then there is another question about from Dimitris. The question is why and where will more spectrum be needed? Namely, what are the use cases that require massive data delivery? And considering the vast majority of data is consumed indoors, fixed type connectivity seems the primary connectivity solution for keeping Wi-Fi. Okay, now I think the fixed type connectivity, the fiber connectivity, that's really important. And the way I look at it is like the access is going to be wireless, whether it's Wi-Fi, 6G, 5G, 4G, doesn't matter. Your device to the network talks over wireless, and then it goes wireline, is going to be fiber. So I don't see whether it's fiber versus cellular, is that you just need the two no matter where you go. The question is where you go from wireless to wireline and how you do it. I don't know, what do you guys think about that?
Yeah, I agree that the vast majority of traffic will be generated or consumed indoors, and fiber, I think 6G cannot. One of the assumptions that we can be relatively certain that has to be taken into account is that fiber will be there to deliver this high capacity. So then, yes, Wi-Fi is the predominant technology indoors at the moment. There is no reason at the moment to say that it might not be, but again, if this 6G loosely defined includes multiple technologies, then we could say that Wi-Fi is part of 6G or etc. I'm not a marketing guy. I'm not sure whether, I don't know, the mobile people and the Wi-Fi people would be happy to have that, but I'm just saying in the network of network definition or of 6G, that could be the way to say it. Then it is quite important also. One thing that I wanted to address is that what happens is that the vast majority of the traffic will be local. And then there will be less amount, like order of magnitude, fewer data that will actually be from one location to another location. This is in general. So if we look, for example, about connected cars is we cannot think that all the raw data will actually happen. And this is actually the assumption that we had 10 years ago. We thought that all the data generated by cars would be just delivered to the cloud or somewhere. There would be some computation and come back with some decision, right? And was the requirement for have very low latency, et cetera, et cetera. Reality is that actually for many, many reasons, most of the data, 99% of the data actually stays within the car. And that has very tight constraints, for example, in terms of delay, computation, bandwidth, et cetera, et cetera. Then there will be some data that has to go back to the internet or to the access network, et cetera. And that actually has lower requirements. And we need to acknowledge that and to design for that. And this is the same thing for the metaverse. We were talking about the metaverse, the equipment that we are seeing for the metaverse are, these equipment, maybe it will be smart glasses or even some lenses for the eyes. They won't have the computing power or the power also to transmission power to actually communicate with the base station that is far away. So what will happen and what is expected to happen for what we know right now, and in 5 years, I might look at this video and just laugh myself at myself, but what will happen is that there will be a computing device that will be very close to us, that will deal with all the raw information, the signal processing, et cetera, and then fetch additional information or combine additional information coming from somewhere else, but with a lower requirements. And this is, I think, how the assumption that we can make for future high capacity, highly scalable and versatile networks for the future.
I agree with that.
That's a good way to sort of think about the specific use cases, because we don't necessarily know what the use cases are, but we need to think about possible use cases as needing more or less of a local processing, and we need to enable that to enable the use cases. So I think it's crucial to do that. It's not just the access. Yeah. Okay. Ern, go ahead.
So yeah, we're kind of on the road to that already with edge computer, edge networks. We're at the very kind of, the beginning, the starting gate for that. But that's kind of the model that will eventually evolve into exactly what you said about having a high capacity computing device near what you're going to be doing, because you're absolutely right about the amount of bandwidth that the metaverse and these virtual devices to make experiences real, to make them believable other than two-dimensional stick figures, will require a lot of bandwidth. So the devices themselves that you're going to be using, and I'm going back to the old Google Glass or whatever that, where you stick your phone onto it, and the phone will be the rendering device that will have to really create some of that. But right now, they just don't have the capacity. So is there going to be a node 6 feet away that's going to be talking to that telephone left and right, and all this data is going to be generated, and then the phone is just going to simply use a small part of it to be the rendering device? That's an interesting concept. But the thing about it is, and if you go, I go to Star Trek on this all the time, is that at some point we're going to have holograms. Now, if you think about holograms, I can't imagine how much bandwidth something like that is going to take to create, Captain Kirk in your living room and you're having a discussion with him or something like that. That's a long way off, but I mean, that's how far forward I think, and how it's a good idea of the demands that either the metaverse or, the IOX or whatever it is going to need at some point. And the fertile playing field for that right now, and I'm going to set off a topic here, is millimeter waves. And now I'll quit with that and let you guys take over.
You mentioned the M word. I'm surprised that it didn't come up in the questions because usually the metaverse dominates everything. So we're gonna get back to there, but why don't we just take another question and then I suggest we move beyond the regulatory stuff and standardization. There is one question: is 3GPP the best standardization body for a non-cellular wireless technology? And I think here the assumption is that 3GPP will just do the cellular bit, and then there would be like IEEE, ETSI, and then other organizations doing others. And I think we want to keep it that way because, again, diversity, it's a good thing. Now, the question though is, should 3GPP work on Gs? Like, do we need 5G, 6G, 7G, or should we just have a more continuous model like it has been the case for like a IEEE? So we have Wi-Fi 6 and 7, but those are marketing terms. They're not internal to the IEEE. IEEE doesn't know anything about, in fact, doesn't know anything about Wi-Fi. Wi-Fi is just outside IEEE. So is it, as we have a continuous sort of evolution path, do we need Gs, or should we just have a gradual evolution?
Well, my point of view is that Gs are useful to to governments, I would say, and policymakers, just because it is useful to give a label to something that you're aiming for. It is part of the communication or political communication. You need to just be able to express in few words, like a slogan, something, a name, that's something that people can relate to, or something that when you're asking for the budget for R&D, for further R&D for communication, you need something easy that people can more or less understand. So, but yeah, commercially, and Ern was talking about that, or at least mentioning that for mobile operators, it might be slightly different, the game. Sweating the 6G brand will be even harder than for 5G. In particular, if there is, again, a network vision, where the mobile operators will be only, we won't have the ability to control end-to-end the experience of the connectivity for their customers, but they will be only delivering part of the connectivity of a much bigger connectivity network, essentially. So my answer is that probably 3GPP should focus and will continue to focus on cellular technology, and IEEE on their technology, and so on. Hopefully, there will be some place where these standards will actually work better together. And that might not be, for example, the ITU or a WRC, it's a World Radio Conference, where usually you're talking about cross-border coordination, et cetera, et cetera. So it might also, the WRC, the World Radio Conference, and the ITU processes might have to reflect this potential new reality in 10 years.
Yeah, absolutely. Yeah, so go ahead.
Yeah. I mean, who knows, in 10 years, 15 years, we may have something like the International Global Wireless Association, of which the IEEE and G3GPP and European Wire, they're all part of the players trying to, come up with a universal standard where everybody can play. But boy, there's going to be some people kicking and screaming on that.
Oh yeah, I think that would be a good thing, but the likelihood of that happening, because our mobile operators are basically the major drivers behind the 3GPP, they have quite different view. And now I don't have much time, so I would say let's just move to that. And there is a question here from John about what will a mobile network operator look like when 6G arrives commercially? How will they make their money?
I think there'll be a
And
dinosaur.
that kind of gets into also the issue of the metaverse finally. Let me tell us what you think, and then I'll chime in. Who wants to go?
I'm just going to say, I think the network operator as we know it today will become extinct at some point.
Okay,
And then that's
a good prediction there. That's not okay. So what do you mean? Why are they going to get extinct, and what does that mean?
Simply because they need to become, again, you've got the two I always point to are, Alphabet and Amazon, and then IBM's out there. There's all these other players out there. It's not about the technology anymore, it's about the service. And the mobile operators, for the longest time, they were just dumb pipe providers, and it took them forever to get into the fact that, oh, we need to be a virtual service, or we need to be this, we need to be that. And they're coming along now, but they're evolving. And the evolution of them is not going to be controllers of the frequencies. And I think Pasquale alluded to some of that. They're not going to control the frequencies anymore the way they've been controlling them over the years. There's going to have to be some sort of a global coordination body. And I'm talking way out. I'm talking beyond 2030 probably. That's going to have to put all this together. And these network operators is going to be a cog, a cog on the wheel of wireless interoperability.
Well, that is quite something. But I mean, don't you think that, there is a sense in which the mobile network, like the countrywide network, you need to have a mobile operator or someone to do it. Maybe not, I don't know. But that, to me, that seems like for indoor coverage, the role, I think it's going to change. But you still need it, right? Pasquale, what are your thoughts on that?
I don't know. Like I agree with Ern that the current model or revenue model of mobile operators is already showing, and I'm being, this might be the understatement of the year, like showing some challenges, right? So what will happen? Yes, I think there will still be somebody providing cellular connectivity, and that we can call it mobile operator, but their revenue model will be completely different. One way, I was just thinking, like one way could be that actually you don't pay for connectivity when you get your, you pay for the service that you're providing, that you want to access, and whether that is through a device or through a particular application or something like that. And when you pay for that, that money will also go to the connectivity ecosystem. How that is shared, I have no idea. How that is, how will that work? I don't know. But it seems already very challenging now that there are no longer, our SIMs are becoming obsolete and there are eSIMs. So we're already like challenging the situation for mobile operators to just have one contract, one person, one mobile phone, etc., etc. Now, when we are thinking about possible different networks, then how you monetize who the user is paying who is the connectivity provider. There might be 20 connectivity providers at the same time that they need some money. They're all providing some type of service. So how does that work? Actually, we might have to flip completely the idea. Instead of thinking like there is a network that is providing a service and people connect to the network and pay, I am a user or I'm a business, I'm running a particular application or something like that, which I pay. A part of the money that I pay goes for the connectivity service. What happens there? I have no idea. That would be super fun to find out.
So is that 6G, going to make money for operators or not? And you said, people didn't pay. So operators tried to charge people for 4G, didn't work. 5G didn't work. There's no reason for me to think that would work for 6G either. And so I think that, you wouldn't really see it as a direct way to make money. But so the question is that if you don't make any money, why would you then deploy it?
My quick answer to that, since we're starting to run out of time, is that the bandwidth that 6G can provide will be a fertile ground for new applications. And that's where the money's going to be. That's true to some degree with 5G already, but it's going to just be that much more expansive when it comes to 6G. So forget it at 6G and say, hey, look, I've got 300 megahertz of spectrum right here. Look what I can do with that.
Yeah, absolutely. Now, we have a few minutes left. Why don't we talk about the metaverse? My view of the metaverse is that it's going to be mostly Wi-Fi, because it's going to be mostly indoors, and that's what we need. The question is whether can Wi-Fi support it, and my answer is for most of it, yes, it can. But I know that that's kind of an somewhat unpopular with some people answer. What do you guys think? 6G, does 6G need the metaverse, or does the metaverse need 6G?
I think the metaverse needs connectivity. 6G needs use cases, and whether there is an overlap has to be seen, but I wouldn't make the link directly. What we know at the moment is that metaverse is delivered through Wi-Fi, or if we want to take a step back and not just call the specific technology to a metaverse, we required a short range connectivity that is a high capacity. Right. That will allow to do the first bit of computation in a local area, whether it is in your room, in your flat, or whatever. It could also be outdoors, but with the first connection from your glasses to your maybe mobile phone that is the computing device. And then there could be another network that delivers. But this is my view. So putting metaverse and 6G at the moment, I don't think it is useful to anybody.
Yeah, absolutely. Ern, what about you?
I tend to agree exactly with what he said. You know, when I look at the metaverse, I am reminded of the movie, I think Avatar it's called, where this guy gets to go off on some sort of a being and live the life he wants to live, but he can't live that life anyway. And to those, you know, kind of like shy, geeky people, I think the metaverse is going to provide them with a whole new life. It would have for me when I was a kid, right? But, you know, I mean, it's virtual. You got to think about it. It's just an input into your visual, your auditory, and eventually your physical feeling of stuff. It doesn't exist. So to support that, you're absolutely right. You need a small, short distance, high bandwidth network. And again, my thoughts go right back to millimeter wave. And I'm not talking about terahertz yet. You know, I'm talking about 100 gigahertz to 300 gigahertz, what they like to call the sub-terahertz. But it doesn't really matter. And it doesn't matter whether it's 5G, because 5G can do it. It doesn't matter whether it's 6G, because 6G can do it. It doesn't matter if there's any G. There's all kinds of other, there's a company I know that makes something called OTFS, orthogonal time frequency space modulation, which is a 3D modulation model that works with the power of the data, or the power of the frequency, and not the frequency itself. So it's actually frequency independent. And that's been around for a while. I've talked to that company a couple of times. I think that technology is great, but I'm bringing it up because my point being is that we don't really know what's coming down the pipe sometimes that may actually work as a solution to some of the demands coming out of the marketplace.
And actually, I would say that I would question the whole concept of the metaverse as something that all of a sudden we wake up one day, the metaverse is here. I just don't believe in it. It's just, there is some element of the metaverse, it's already available, and it's not. I think it's kind of a useful concept to have, but in reality, it's just gonna happen gradually, and we don't actually know exactly what's going to be. And that's the cool thing about it, right? I mean, we don't know, but we want to have the infrastructure that will allow whatever we want to do, and that's going to be all the way from 4G to 6G, Wi-Fi, and everything, right?
I can't wait to sit in my starfighter, you know, and do my thing out in the universe somewhere.
Absolutely. Okay, I think that we are at the top of the hour. We could be talking about this forever. I think we went through like a third of the things we wanted to talk about.
Yes.
And
More opportunities.
absolutely, more opportunities. So stay tuned, and thank you for joining. And Kendra, back to you.
Okay, great. Well, that will conclude our webinar today. Thank you so much to our speakers for that great conversation. And thanks to our audience members for those wonderful comments and questions. A recorded version of today's webinar will be available at the sensafili.com website in the coming days, so find it there. And we look forward to seeing you at future events.
Well, that was so much fun.
Thank you.
Thank
Bye,
you.
everybody.
All right, you guys. Now, Pasquale, so nice to have worked with you. And Monica, it's always good to see you. Okay. Talk to you guys soon.
You
All
too.
right.
Bye-bye.
Happy
Thank
holidays. Happy
you.
New Year.
Thank you. Bye.